Good morning, students. Today we are going to discussing paper paper 7, unit 2, steroids and hormones. Steroids and hormones. Steroids and hormones. Steroids and hormones. So steroids, when the steroids, a steroid can be defined as a compound which can give rise to Diels hydrocarbon on selenium dehydrogenation. When steroids are reacting with selenium dehydrogenation at 300 degrees Celsius, they gives selenium they gives Diels hydrocarbons are the products. When these steroids reacting with selenium dehydrogenation at 420 degrees, then gives chrysin and piscine picking picking is the product will be formation takes place. This is the characteristic properties of the steroids. The formation of deep hydrocarbons when steroids on 360 degrees Celsius heat and psyllium dehydrogenation and chrysin and piscine on picking on psyllium dehydrogenation at 420 degrees. Then on steroids, these are the characteristic properties. When cyclopentanophenolphthalein, that is yield hydrocarbon skeleton, when attached to OH function group known as sterol. Okay, when known as sterols. In these sterols, we are discussing cholesterol. Occurrence of this cholesterol, the cholesterol is mainly occurred in brain and spinal cord, gallstones, and fish liver oil, and many are sources. Next, we are going to discussing structural elucidation of cholesterol. The structural elucidation of cholesterol. Structural elucidation of cholesterol. When in the structural elucidation of cholesterol, that molecular formula of cholesterol is C27H48O. When this cholesterol C27H46O, when this cholesterol molecular formula is C27H42O, it's C27H46O. Molecular formula of cholesterol is C27H46O. C27H46O. When cholesterol under platinum hydrogen reduction, then forms cholestanol. The teens, and when this compound reacting with the bromine, then dibromocholestanol will be formation takes place. The formation of these two compounds indicates in the cholesterol there is a one double bond is present. When this cholesterol under is reacting with stick anhydride in acylation, monoacyl derivative of cholesterol will be formation takes place. That in this case, there is a hydroxy group is present. When this cholesterol undergo oxidation, they gives cholestanol is the formation. Cholestanone will be formation takes place. That indicates that aliphatic hydroxy group is secondary alcohol is confirmed. When this cholestanone undergo zinc amalgam HCl, then forms cholesterol. This cholesterol molecular formula is C27H48. That indicates it is a cholesterol is a tetracyclic compound. Tetracyclic compound, and double bond equivalency is equal the tetracyclic compound. Double bond equivalency is 5. That indicates 4 rings, one double bond is present. When this steroids, when this cholesterol undergo selenium dehydrogenation at 360 degrees, that then produces Diels hydrocarbon is the product will be formation takes place. The formation of this Diels hydrocarbon indicates there is a phenanthrene skeleton is present, or there is a Diels hydrocarbon, reduced Diels hydrocarbon skeleton is present in cholesterol. Then position of hydroxy group and double bond. When here in this case, when cholesterol a reaction with uh, hydrogen in presence of platinum, then followed by oxidation, then forms cholestanone. This cholestanone compound reacting with HNO3 then forms dicarboxylic acids. This dicarboxylic acid compound react on heating at 300 degrees centigrade, undergo pyrolysis, then gives ketones are the product. Ketones are the product. So from this reaction, here this from this reaction, so the dicarboxylic acid formed to be have some same number of carbon atoms. Here the dicarboxylic acid having 27 carbons and cholesterol having 27 carbons. So in this case, that means here this dicarboxylic acid found to be the same number of carbon atoms to that of diketones, that ketones. Therefore, that keto group is present in the ring, is not on side chain. So that indicates there is a double bond and hydroxy groups are in present in different ring. Okay. Next, we are going to blank rules. When 1,6 dicarboxylic acid or 1,7 dicarboxylic acid under reheating with acetic anhydride, then loss of carbon dioxide, they forms ketone having with same number of carbon. When 1,5 dicarboxylic acid heating with acetic anhydride under each, then forms anhydrates with loss of one carbon atom, with loss of carbon atom. So that indicates when ring of size A, when we are going to ring of size A, when this compound cholestanone, when this cholesterol under oxidation then gives cholestanone, this cholestanone reacting with the HNO3 then forms 1,5 dicarboxylic acid. When this 1,5 dicarboxylic acid upon heating then forms cyclopentanone with with loss of one carbon atom. That indicates ring A is a six-membered ring and having one hydroxy group on ring A. When ring B, when we are going to discussing ring B, when this ring B also found to be a six-membered ring and with one double bond is present. Next, position of double bond, here the position of double bond. So when cholesterol reacting with hydrogen peroxide in glycolic acid, then produces cholesterol triol. So in this cholesterol triol, so in this cholesterol, one hydroxy group is there, and when this compound cholesterol under reacting with hydrogen peroxide in acid medium, then forms cholesterol triols. That means in this compound, two extra hydroxy groups are present. So in this totally three hydroxy groups are present in cholesterol triol. When this cholesterol triol under oxidation, they gives hydroxycholesterol dione product will be formation takes place. That means here two hydroxy in these triols, two alcohols and are involved in the conversion of ketones. That indicate these two alcohols are secondary. Tertiary alcohol does not involve in the conversion oxidation. Therefore, that is retained as a hydroxycholesterol dione. With this hydroxycholesterol dione reduction with zinc in acetic acid, then forms cholesterol dione will be formation takes place. The tertiary alcohol involved in the loss of water molecule then forms cholesterol dione will be formation takes place. This cholesterol dione undergo oxidation then gives tetracarboxylic acid with 27 carbon atoms. This cholesterol dione under reacting with hydrogen then produces pyridazine is a product. So here the formation of tetracarboxylic acid with the same number of carbon atoms, 27 carbon atom with respect to the cholesterol cholesterol. So that indicates the double bond and hydroxy groups are in different ring. The double bond and hydroxy groups are in different ring. We know from blank rules. A ring is having six-membered ring and hydroxy group. B ring is a six-membered ring and double bond will present. It is also confirmed that formation of tetracarboxylic acid with same number of carbon atom indicates that hydroxy and double bond in different ring. When formation of this dikete cholesterol dione reacting with hydrogen then forms pyridazine indicates that two ketones are in gamma to each other. The two ketones are gamma to each other. This is a reaction here. Cholesterol undergo dihydroxylation, they forms cholesterol triol. This cholesterol triol, here three hydroxy groups are there. These three hydroxy groups are, among these three hydroxy, two hydroxy are secondary, one is tertiary nature. This secondary two secondary hydroxy groups are, two secondary hydroxy groups are, Two secondary hydroxy groups are undergo oxidation and tertiary hydroxyl group are remaining, that is hydroxycholesterol. This hydroxycholesterol undergo elimination of water molecules in presence of zinc in acetic acid then forms cholesterol, then forms cholesterol dione. This cholesterol dione undergo oxidation with gives tetracarboxylic acid with the same number of carbon atoms, indicates cholesterol having hydroxy and double bonded different ring. This cholesterol dione reacting with hydrogen then forms pyridine derivatives. So this is also confirmed here. And position of side chain. Nature of position of side chain. When cholesterol reacting with stick acylation takes place, then forms acetyl acetate. Cholesterol acetate will be formation takes place. This cholesterol acetate under oxidation then forms under oxidation then forms under oxidation then forms iso iso isohexyl methyl ketone. Isohexyl methyl ketone will be formation takes place, and another product and estate of hydroxyketone will be formation takes place. So see here in this see here in this see here in this we are discussing here we are discussing here when cholesterol under acylation they forms acyl derivative of cholesterol. This acyl derivative of cholesterol undergo oxidation then forms acetate of hydroxyketone state of hydroxyketone and isohexyl methyl ketone some will be formation takes place. The formation of this isohexyl methyl ketone indicates there is a this side chain is present on cholesterol ring. So yeah, this is a Barbier-Villang degradation method. This is a mm, conversion of higher carboxylic acid to lower carboxylic acid. This is a degradation reactions of carboxylic acid. So in this case, so in this So this some cyclohexane is there. This cyclohexane, this is a position of side chain means here the formation of isohexyl methyl ketone and ketone indicates this is a side chain present at C17 position of cholesterol ring is confirmed. This is side chain at C17 position of cholesterol is confirmed by using this following degradation reactions, Barbier-Villang degradation reactions. The position of side chain at C17 position is confirmed. This is a Barbier-Villang degradation reactions. So in this next one is position of angular methyl groups. Next one is position of angular methyl groups. So in this acyl derivative of cholesterol, this is in this compound. So in this compound cyclopentone ring, in this here 17 carbon atoms are present, and um, here we are getting here we are getting 7 carbon atoms. 17 plus 7 carbon atoms are present, or only 25 carbon atoms are present, but the molecular formula of cholesterol indicates 27. That means 27 minus 25, two carbon atoms are there. That is the two carbon atoms are maybe angular methyl groups. In the cholesterol structure, two angular methyl groups are there. Therefore, we can determine the position of angular methyl groups. So from this, we know that two angular methyl groups are there. Now that the two angular methyl groups are at C10 and C13 position is there. That is, we are evidence for the angular methyl group at C10 position. C10 position is when cholesterol undergo when cholesterol undergo when cholesterol undergo oxidation, then forms cholesterol dione. When this cholesterol dione cholesterol will be formation takes place. This cholesterol under oxidation, they give cholesterol. This cholesterol undergo oxidation with cholesterol undergo oxidation with oxidation with HNO3, then forms keto acid. This keto acid undergo Clemmensen reduction. This keto acid undergo Clemmensen reduction gives carboxylic acid. This carboxylic acid undergo twice Barber-Villang degradation, then gives tertiary carboxylic acid. In the tertiary carboxylic acid, there is an angular methyl group is there. That angular methyl group is the position of angular methyl group at a C10 position in cholesterol is confirmed. Next one is evidence for angular methyl at C13 position. Evidence for the angular methyl group at C13 position. When cholesterol undergoes selenium dehydrogenation, forms deals hydrocarbon, then forms deals hydrocarbon, and chrysin will be formation takes place. The formation of this chrysin and deals hydrocarbon, the angular that methyl group is the position of C13 is evidence for that. So this is the evidence for the formation of angular methyl groups at C10, C13 position. So based on all the reactions, we have to confirm it as a stereochemical structure of cholesterol. That hydroxy group at C3 position and double bond at C5 and C6, and one of the methyl angular methyl C10, another one is C13, and side chain at methyl isoxyl ketone side chain that is represented C17 is established. This is a synthesis of cholesterol. This is synthesis of cholesterol. Next, we are going to discussing hormones. In these hormones, we have two hormones are there: estrogen and testosterone. Estrogen and testosterone is there. First, we are going to discussing estrone. First, we are going to discussing estrone. This is a estrone. That's a structural determination of structural elucidation of estrone. In this structural elucidation of estrone, the molecular formula is C18H22O2. C18H22O2. In this estrone undergo oxidation, monoacyl derivative will the estrone undergo reacting with acetic anhydride, then forms monoacyl derivative. This estrone undergo methylation with methyl anhydride, then forms monomethyl ether will be formation takes place that in case one OH group is present. Then this estrone soluble in alkali solution and forms diazonium salts with diazonium salts. Diazonium salts then coupling reaction will be takes place that indicates that the hydroxy group is a aromatic OH, phenolic OH is conformed. When this one is their ketone, when this estrone reacting with hydroxylamine hydrogen chloride then forms oxames, and this oxames that indicates there is a carbonyl group is present. This estrone gives negative test with tolerance and failings that indicates uh, there is a ketone will be present. When estrone undergo reduction with hydrogen platinum, then forms octahydro compound. So from this octahydrocarbon compounds, there is a eight double bond equivalency is eight. So octahydro compound eight double bond equivalency is there. That indicates one carbonyl and six rings are there. Six aromatic benzene double bonds are there. So therefore, the octahydro compound will be formation takes place. So we know that here one hydroxy group is phenolic hydroxy group is there. Next, we are going to determine the position of phenolic hydroxy group. When estrone reacting with methyl anhydride, when estrone is reacting with methyl anhydride, when is estrone reacting with methyl anhydride, then monomethyl ether of estrone will be formation takes place. This monomethyl ether of estrone undergo Wolff-Kishner reduction. Then intermediate undergo selenium dehydrogenation. Then forms 7-methoxy 1,2-cyclopentane skeleton will be formation takes place. The formation of the 7-methoxy 1-cyclopentane 7-methoxy 1,2 cyclopentano indicates the position of 7-methoxy is the position of hydroxy group in the estrone. Therefore, that hydroxy group, phenolic hydroxy group are present in estronate C3 position is confirmed. Next, position of angular methyl group and keto group. Position of angular methyl group and keto group. So when estrone reacting with diazomethane forms monomethyl ether of estrone. Monomethyl ether of estrone. This monomethyl of ether of estrone reacting with methyl magnesium iodide. Methyl magnesium iodide. Then the product is monomethyl monomethyl ether of estrone will be formation takes place. This monomethyl ether of estrone undergo reactive methyl magnesium iodide, then forms product 1A. This product A undergo reaction with KHSO4 and followed by hydrolysis, then undergo loss of water molecule, then formation of product B. This product B undergo reduction with the selenium, then forms product C. The product C is the 7-methoxy 3-3 dimethyl 1,2-cyclopentano-phenanthrene. 1,2-cyclopentano-phenanthrene formation takes place. The formation of this product C indicates angular methyl group at angular methyl group C13 and angular methyl group assumed to be present C13 position because of formation of this 1,2 migration of the compound. And and the keto group at C17 position is present. That is adjacent to position is takes place. So this is a structure. Next one we are going to synthesis of estrone. In the synthesis of estrone, 6-methoxy tetralone, the 6-methoxy tetralone reacting with vicryl acryl magnesium bromide, vinyl magnesium bromide, vinyl magnesium bromide. This vinyl magnesium bromide undergo addition reaction with the carbonyl compound gives alcohols. Next, it is involved in the Diels-Alder type reaction. Then followed by protection of this carbonyl compound, and for deprotection of this carbonyl compound, then gives our uh, estrone product will be formation takes place. Next one, testosterone. This is a testosterone. In this testosterone, this is a testosterone. Testosterone is a tetracyclic compound. Testosterone is tetracyclic compound having alpha beta unsaturated carbonyl compound and hydroxy group is present. When testosterone molecular formula is C19H28O. Testosterone undergo bromination, they forms dibromo derivative and reaction with hydrogen palladium then forms dihydro testosterone. So that indicates one double bond is present. When this testosterone reacting with hydroxylamine hydrogen chloride monoderivative and negative with the talents and valence, that indicate ketone is confirmed. When testosterone hydroacylation, they forms monoacyl derivative, and monoacyl derivative oxidation gives diketo product. That indicates two hydroxy groups are present in testosterone. That indicates secondary hydroxy group is present in testosterone. So we know already double bond equivalence is 6. That indicates 4 rings, and two double bonds are there. Orally 6 double bond equivalency is there. When this testosterone, when this testosterone undergo oxidation, they forms an androst 4 in 117 dione. From all this above, conclusion that of structure of testosterone is confirmed like this. Okay, now it is just confirmed. Based on this reaction, the testosterone structure is confirmed like this. And now we are going to synthesis by confirmation. So these are synthetic methods involved in the testosterone. These are synthetic steps involved in the testosterone. So first one is Birch reduction, followed by keto. First step is Birch reduction, then followed by um, keto-enol tautomerism type. Then it is undergo Michael addition, followed by intramolecular allyl condensation. Then alkylation takes place. Then elimination of water molecule, intramolecular allyl condensation, and production of dihydroxy diketones. And finally, we have to synthesize our testosterone compound. Next, we are going to discussing Unit 5, routinoids and four pyrines. Next, we are going to discussing routinoids and four pyrines. Routinoids and four pyrines. When this first, we are going to discussing routinoids. So in this routinoids, our syllabus is rotinone is present. In this syllabus, rotinone is present. So according to this from we are going to determine the rotinone is present. Next, we are going to discussing rotinone skeleton, structure determination of rotinone. Structure of rotinone we are going to discussing. So the molecular formula of rotinone is C23H22O6, C23H22O6. Molecular formula of rotinone is C23H22O6. When this when this rotinone under G cells method, then gives two silver iodates, that indicates two methoxy groups are present in rotinone. When the rotinone forms oximes, that indicates that rotinone forms oximes with hydroxylamine hydrogen chloride. That indicates there is a carbonyl group is present. They gives negative tolerance and failings, that indicate that carbonyl is a ketone is confirmed. When rotinone reacts with acetic anhydride in presence of sodium acetate, gives enol acetate. When rotinone reacts with acetic anhydride in presence of sodium acetate to gives enol acetate, that is enolization, that indicates enolizable hydrogen is present at alpha position in with respect to the carbonyl group. Enolizable hydrogen is present at alpha position of carbonyl group is present. So that is enolizable. Therefore, they gives enol acetate. When this rotinone, when this rotinone undergo reacting with acetic anhydride iodine, they forms dihydroestrone. Rotinone undergo reacting with acetic anhydride iodine, then forms dihydroretinone. Dihydroretinone will be formation takes place. This dihydroretinone there is no undergo uh, enolization. There is no possibility of enolization takes place when this rotinone dehydrorotinone when this rotinone reacting with esticated iodine, they gives dehydroretinone will be formation takes place. These dehydroretinone reacting with alkali KOH, undergo reacting with alkali KOH, they forms a known compound derisic acid will be formation takes place, and derisic acid will be formation takes place under zinc dust distillation. Under zinc dust distillation, this rotinone under zinc dust distillation, this rotinone under zinc dust distillation, they forms rotinol is a product will be formation takes place. Rotinol will be formation takes place. This rotinol furtherly under hydrolysis they forms deritol will be formation takes place. The formation of deritol with points out the otroxin skeleton is present in rotinone. The formation of deritol skeleton point out that rotroxin, the formation of deritol points out that rotroxin skeleton is present in rotinone. Rotroxin skeleton is present in rotinone. So these are the some of the degradation reactions of rotinone. So undergo oxidation, they forms dehydroretinone. This dehydroretinone zinc they forms derisic acid. This derisic acid undergo hydroxylation. They forms derisic acid. Derisic acid they forms derisic acid. This derisic acid under again oxidation formed resic acid. Resic acid. So from these above reactions, derisic acid forms a monoestate monoestate with acetic anhydride. One OH group is present in derisic acid, gives off reddish violet color complex with nat, nat, neutral FeCl3 indicates there is a phenolic group is present. Derisic acid forms a monooxime derivative with hydroxylamide. It gives a negative test for the aldehyde. It indicates the presence of ketone group. Gissel method point out that two methoxy groups are present. Derisic acid is an esterification with the disomethane point produces monomethyl ester indicate the presence of one carboxylic acid group. Rotinone heating with alkaline in presence of tubic acid and produces tubic acid. Rotinone heating with alkali, it produces tubic acid. It forms a dehydrotubic acid, isohydrotubic acid, tetrahydrotubic acid, catalytical hydrogenation. The formation of the formation of products depends on the concentration of catalyst and presence of hydroxy groups. So this is a rotinone. This rotinone undergo heating with base, then gives tubic acid. The tubic acid undergo catalytical hydrogenation. They forms dihydrotubic acid, isohydrotubic acid, tetrahydrotubic acid as the product will be formation takes place. So based on these structures, we there is a presence of carboxylic carbonyl group in the hydrogenation product. Point out that tubinol is attached to the derisic acid to carbonyl group in the derisic acid. So tubinol, tubic acid, and derisic acid. The structure of derisic acid and rotinone is shown below. This derisic acid and rotinone will be product will be formation takes place. This synthesis of degradation reactions of the formation of reactions when rotinone undergo dehydrogenol formation, uh, enol ester will be formation takes place. Degradation reaction when rotinone undergo oxidation, oxidation, then elimination of hydrogen molecule, then forms dehydroretinone. This dehydroretinone undergo hydrolysis, then forms rotinol. This rotinol again undergo oxidation gives derisic acid. This derisic acid deric acid and rutubinol will be formation takes place. This deric acid when undergo again oxidation then forms resic acid is the product. So next, this is a synthesis of involved in the rotenone structure. The synthesis of involved in the rotenone structure. Next, porphyrins. So this is a porphyrin. The natural porphyrin pigment contains a complex cyclic structure formed by the linkage of four pyrrole rings through the methylene bridges. These structure are known as porphyrins. Two most important derivatives of porphyrin are hemoglobin and chlorophyll. Hemoglobin and chlorophyll plays a very important role in biological process. So by replacing of hydrogen atom of beta position of porphyrin nuclei in porphyrin in various such groups such as methyl, ethyl, and vinyl groups, etc. Different porphyrin are attached. So here these are the methylene bridges are present in porphyrin and structure of hemoglobin. This is structure of hemoglobin, and we are going to this is a very lengthy synthesis for the synthesis of heme. It is involves in a lot of steps and 3 4 pages. So next one, this is a chlorophyll. In this chlorophyll, magnesium is present in the cavity of a porphyrin ring. In hemoglobin, that is iron is present in the cavity of porphyrin ring. So this is a chlorophyll, and these are the hemoglobins are present. So porphyrin ring, naturally porphyrin compounds.